Hi there. So in preparation for the test, Will came in and asked me a few questions, and I then used him as a guinea pig in a quick lab. And so let's watch that lab right now, and I want you to take data as we do it. So he's going to slide the block from the left-hand side of the screen over to the right-hand side of the screen. So let me rewind that and let's watch it now. All right, hi, Will and I are in the lab, and we're going to do a quick little experiment before the test. Okay, go ahead, Will. Okay, did you see how long that took to slide over? So I'm going to rewind it, and I want you to look to see how long it takes to slide from the left side of the screen to the right side where it stops. Okay, so estimate that time. You can use a stopwatch or you can use your heartbeat or whatever, but try to estimate that time. So I'm going to rewind it one more time. Here we go. Will and I are in the lab, and we're going to do a quick little experiment before the test. Okay, go ahead, Will. Okay, so how long did it go? How long was it sliding across the screen from the left-hand side to the right-hand side? All right, so think about that and record your data. Pause it now to think about it, maybe rewind it or whatever. Okay, also try to get the distance it traveled, okay, from the left side of the screen to where it stops. Notice it stopped right there. Okay, I didn't pause the video, it actually stopped. Perfect. Okay, that stopped. So we know it has to be more than a meter because this meter stick is laying here and it traveled farther than a meter, but probably less than 2 meters. So pause the video right now and figure out how long it took to slide across the screen. Okay, so you got your values, and I'm going to cheat here. I'm going to look up what Will thought it was. Will said he thought it was 1.25 seconds to slide and 1.75 meters. Okay, perfectly legitimate estimations there. So whatever you guys get is perfect. Just live with that. Okay, or you can use Will's and use Will's data. So what I want to do is I want to figure out what was the velocity that it had when it left or when it entered the screen over here on the left. What was that velocity? And I also want to know what was the acceleration that the object had as it slid across the floor. In this case, it will be a deceleration or an acceleration that is negative, okay, because it's going to be slowing down as it travels to the right. All right, so pause the video, try to figure out what the initial velocity is, and then figure out what the final velocity is here. And I will do the same. I'm going to pause the video, I'm going to solve the problem, and then we'll compare answers, okay? Again, I'm going to use time of 1.25 seconds and 1.75 meters. All right, come back in a few seconds and I'll see you. Okay, so let me get you started. I drew my picture, and if you don't have a picture, you probably should. For sure, you should list your known values here. Okay, so we're looking for the initial velocity, but we're also looking for the acceleration. Now, which one should we find first? Okay, we have to find the initial velocity first because it's in every single equation. So we can't find A until we know what VI is. So what do we have? We have T, delta X, and V final. We don't know A. We don't know VI. So what equation does not have A in it? What equation does not have acceleration? Oh, it's the third equation. So that's one we're going to start with. Okay. All right. And what do we know is 0? We know that the V final is 0, so that guy disappears. We love zeros. So that makes this equation a lot easier to play with. 1/2 of V initial T, because 0 plus V initial is just V initial. Okay, and what are we looking for? We're looking for V initial. So how do we get rid of the 1/2? We multiply both sides by 2. And how do we get rid of the T? We divide both sides by T. And that is what VI equals. Okay, so however many steps it takes you to go from here to here is fine with me. All right, so now we plug in 2 times delta X. I'm going to go with Will's estimation. I like that. 2.75 meters divided by T. Again, using Will's number. Okay, and then we can pause this calculator. Okay, and through our calculator, we get that the initial velocity, the velocity that it had on the left side of the screen, was 2.8 meters per second. Okay, yay. Now let's find out what the acceleration was. Now that we know the initial velocity, we can use any of these equations over here to find acceleration. So let's use maybe the first one. V final is equal to AT plus V initial. Right? And what do we know? We know that V final is 0. We're looking for the acceleration, so we need to get that term by itself. We've got to get rid of that one first. So we subtract both sides. And now we got to divide both sides by t. Okay, we plug in our numbers. We hope we get this right? If we miss this, we're going to miss the acceleration, so we have to be careful. Physics is hard. And then our time is 1.25 seconds. Did the units work out? Meters divided by seconds is a meter per second squared. So yes, it works out. So I'm going to pause it here again and do the calculation. Okay, so I get negative 2.24 meters per second. Why is it negative? Because it's slowing down, right? The object slows down. So if the velocity is moving this way, if the object is moving to the right, then the acceleration has got to be to the left, has got to be negative, because the object is in fact slowing down. We saw it slow down as the block slid across the ground. It slows down because of friction. One last thing I want to point out is if we miss this problem, then we're going to miss this problem. Okay, so one thing we can do is we can check our work. You should, if you have time, it's always a great idea to check your work. So what you can do is you can, for example, take another equation, perhaps it has VI and has A in it, like this, and we can do a calculation. Maybe we can solve for the for final velocity. Let's try that. Let's do a check. V final squared is equal to 2A delta x plus V initial squared. So let's just plug that into the equation and see what we get. So that's the value that we get. We hope it's right. Okay, times delta x, Will's value of 1.75 meters, plus the initial velocity, what we got here, 2.8 meters per second squared. Okay, so I am going to pause the video here and do the calculation. Let's see what we get. Okay, so when I did the calculation, I got on the left-hand side, I got this number, 2 times negative times 1.75 becomes this, and 2.8 squared becomes this, and of course if you take a negative 7.84 and add it to a positive 7.84, you get 0. So therefore the final velocity, this is really final velocity squared, but if you take the square root of 0, it's also 0, so the final velocity is 0, and we are so excited because the left-hand side equals the right-hand side, so we are pretty sure that our numbers at least worked out. Now, whether or not Will was correct with the time and the displacement, who knows, but you know, with these numbers, this is what you would get for the initial velocity and also the acceleration. Isn't this powerful? Isn't physics really powerful? You can do so much stuff with just a little bit of information. Okay, so that's one of the big takeaways from this class is that science just doesn't make stuff up. We actually derive things and find things out with a little bit of data. Okay, so hope this helps. Y'all take care.